Right, good morning, everyone. I'm having a bit of a challenge. You probably saw me flustering around there. I'm having a bit of a challenge with one of the boards, so we'll bin that one for now. But today, I'm going to be talking about sensors, data, and dashboards. This is an IoT talk. Did any of you go to Nigel Parker's IoT talk yesterday, where he did the data of me? No? This is not that, obviously. I promised Raspberry Pis. There's one there, and there will be some code. So who here has been to lots of presentations so far? So I can't actually see you guys, so I apologize for that. But yeah, good. Have you had death by PowerPoint? Or is it death by pictures, really? Because everybody seems to be showing pictures and like 3 words on a screen. I don't know if that's me. So I'm going to do some of that as well, just so you know. So IoT. What do we know about IoT? The predictions are there's going to be 50 billion devices by 2020. And there's going to be a market value of $11 trillion by 2025. So probably not a bad thing to get into, right? How has it come about? Well, it's come about because cheap sensors. It's come about because cloud-scale computing. It's come about because nearly IP version 6 addressing. All that together, I think, has helped enable what we can currently see as IoT. What does the I stand for in IoT? Internet, right? So it's the Internet of Things. Of course, things have been around for a very long time, right? So if you ever worked on a mine site or anything like that, or anywhere there's a process control network, all of that stuff is run by things, sensors, feeding into great big systems that the operational people look at and kind of go, oh yeah, that's doing what I think it should be doing, or that's not doing what I think it should be doing. And then all that data goes somewhere else and is never looked at again. Kind of a waste, really. So I'm here to talk about Azure because I'm an Azure MVP. So that's the Azure IoT platform, in essence. There's a lot of other stuff. This isn't the only things. I think at last count there were 70 services, 71 services in Azure, so that's quite a broad spectrum of things. But what constitutes the Internet of Things? Over on the left-hand side of that screen, we have things, not surprisingly. So here we have a bunch of devices. Those devices could be sensors. Maybe it's a Bluetooth tag that you've got strapped to an asset so as you know where it's moving. And you've got a device that's reading that ping. Maybe it's a truck. Could be anything, right? So the point being, those things can cost as little as a couple of dollars or as much as several $1 million. Right? Field gateway. There's been a big debate, I suppose, push. Connectivity is always the issue with the Internet of Things. How do you get the data off the thing that's very small, that may be on occasion somewhere else? Well, you do that by having a device that's actually capable of the communication itself. So you can have your things pushing to your field gateway and then up into the cloud. IoT Hub is really probably the focus of the talk today, so that's probably where I'll spend most of my time. But IoT Hub is the ingestion engine. So it's the landing point for the data in the cloud. What else? Insights. So, anybody heard of Lambda architecture? Yeah, more, yeah, a couple of people, good. So, this obviously enables that. You can see cold analytics, hot analytics. So basically what that is an ability to take your data, push it down into some form of cold storage, do some long analysis on it. Also have a hot path where you can do real-time analysis and see things happening. Being able to combine that information. That's, in essence, a Lambda architecture. And the new kid on the block, which was announced at Build, is warm analytics. I think they make these names up, to be honest. But hot analytics, real-time. Cold analytics, archived and batch. Warm analytics is kind of near real-time. And I'll talk a little bit about time and series insights in a little bit. And then, not surprisingly, when you've got all this data, you do need to do other things with it. You can't just store it and just hope for the best. So you need to move stuff around. So there's a bunch of things in here around moving stuff as well and managing state, essentially. And the last thing is that action. So again, if anybody was at Nigel's talk yesterday, you would have seen him using a bot to interact with his data. That's an action. We've got some other things here. Power BI. He used the Power BI yesterday to see insights. And some stuff down the bottom here around integration with other systems, because you may well have something like an SAP off the back of this, so or a logistics system like Dynamics 365 Field Services. So that, to me, is what I like to call the IoT value chain, because having devices means nothing if you don't ingest the data. If you ingest the data but you don't gain insight and take action on that data, then why have the devices? So you need all of that. That's not to say that you need to know all of that, by the way. That's what working with other people is for. So I thought it'd be just quite an interesting little segue to talk about some of the things that I've done that fit that value chain. So, sorry, this is where I'm going to go into pictures for a little while. I do apologize. This is an iron ore train. Very, very long. Now, I come from Perth. That's Perth, Western Australia, hence the T-shirt. In case you didn't guess from my accent that I'm clearly not Australian. Well, I am now. But so we have in Perth probably one of the larger mining towns, I guess, in Australia. We're very, very resource heavy. We have mining, oil and gas, all that sort of thing. All the big towers are at what we call the top end of town. Okay, so I work for a small systems integrator, and we work with some of those guys. So iron ore trains. These hoppers, as they go around, they'll go up to a ship, they'll flip, the ore will go into the ship goes away, and it gets processed. If one of those hoppers fails, it's $1 million an hour that the company loses. So that's value, right? $1 million an hour. So they put sensors on them. They put sensors on them because that way they can tell, or at least help to predict when there might be a failure. Another example. Can anybody tell me what those are? Nigel can. Oysters, yes. So we have a company in Australia who have created a salinity sensor. And you may think, a salinity sensor? They're all over the place, salinity sensors. Why would you create one? Salinity sensors are all over the place, but they also suffer from a lot of corrosion. Right? So in this particular case, oysters, Australia's a large exporter of oysters to the APAC region. Really expensive in Australia, but we seem to ship them everywhere else. Anyway. So when oysters are in the sea and they're growing, they need a certain range of salinity and a certain temperature range. If it goes out of that range, the oysters either die or can become toxic for human consumption. So when it rains, up in the hills, people have to go out into the sea, grab the oysters, and bring them in, because they can be stuck in a freezer and they're okay. So remember what I said about cheap sensors? Cheap sensors doesn't necessarily mean cheap in the context of not many dollars. Cheap means cheap in the context of the value that they deliver. So the organization that created the salinity sensor for this spent $1.5 million developing the sensor for this. But it's accurate, and it can stay in the sea for 5 years. So think about that accuracy. The English language is fairly colorful, I suppose, but if you think about the letter I following a C, it's a fairly soft sound to the C. An O following a C is a fairly hard sound to the C. So I like to think of this as, if you don't get your data right, what you essentially have is crap in, crap out, right? Or psycho, as I like to call it. So they spent a lot of money because any day's production that's lost, $100,000. So we're talking real things. That's a cow. Actually, it's a plastic cow, but you get the point. So what you'll see is a little tag around the leg. So I used to work for Fujitsu in the UK and then in Australia. So Fujitsu developed this thing called the connected cow. So when a cow, let's call her Bessie, is the technical term is in estrus, but it essentially means when she's looking to enjoy herself. She walks around a lot more. Okay, so when she walks around a lot more, it's good for the farmers to put the bull in the field so she can get inseminated. This is particularly good in Japan, where you've got very, very high level cuts of beef. Again, potential millions of dollars just from data. So, I mentioned about IoT, a platform to build end-to-end IoT solutions with a little star. And the little star really is so you don't have to build it all yourself. Because why would you? That's the point of having a platform. It helps you leverage that platform. Excuse me. So, here is Microsoft's Azure IoT reference architecture, unless it's been updated, Nigel. Sorry, Nigel works for Microsoft, I don't. But you can see how that really maps to that other picture that I had around the cold analytics, hot analytics, and everything. Things in blue, as you can see if you've got keen eyes, and it's not reflecting off the screen with the lights, says Azure IoT Solution Component. So that's part of the platform. So over this side, again, we've got devices and gateways. And there's SDKs for that, so you don't have to write it yourself. So it's nice and quick and easy for you to rev this stuff up and get going. In the middle, IoT Hub. I'm going to talk about that in depth in a minute. And then some other stuff. And the arrows here is meant to indicate data flow, as it says. But fingers crossed, if the demo gods are kind and my machine starts working again, I'll show some of this stuff anyway. But the key part really is that a lot of this is just pay-per-use. Start it up, run it, do it when you need to do it. So you're not investing huge value in something that is not delivering value. And again, going back to that conversation I was having about process control networks and SCADA, which is what those are, they're hugely expensive to install that stuff in your mine site. The operators look at it as the data's coming in. It goes into a thing called historians, and then it's forgotten about. Millions and millions of lost investment, in essence. So actually being able to do some stuff that's more real-time, longer-term predicting as well, is very good. So I think Nigel spoke yesterday about machine learning. I won't talk about that today. He talked about that yesterday. But again, it's that ability to take vast quantities of data, and we're talking petabytes and petabytes of data in a typical mine over many years, taking vast quantities of data and doing analysis on it. So you can't do that, or you can do that in the old traditional on-premises world, but it's hugely expensive. So that's the cloud computing enablement. How are we doing for time? So IoT Hub. I mentioned IoT Hub, and that I'll go into a bit more depth. So who here has played with Azure at all? Many people. Good. Fantastic. It is a developer conference. That wasn't a test. Event Hub. Anybody? Yep. 1 or 2 hands. Good. So Event Hub is the platform's large-scale ingestion engine, and IoT Hub is kind of built on top of it. But the reason it's different is because IoT communication is two-way. So when you have devices, yeah, absolutely, you can ingest data and go nuts. But typically, you may have devices, things like field gateways, for instance, which you need to send data to update configuration or query the device, any of those sorts of things, right? So, so you need this two-way communication. So I would strongly urge anybody who's in the audience who's not read this particular white paper to do so. It's written by a guy called Clemens Vastas, as it says there. He's one of the architects, or was one of the architects for Service Bus, and he wrote essentially what is the seminal paper on which the whole security model and communication model in IoT Hub works. So very, very good read. It's quite a long article, but trust me, it's worth your investment in time. But he postulated that one of the big things that you need to overcome is security, not surprisingly. So what you really don't want is a scenario where somebody hacks into your device and sends data up to the cloud, or somebody hacks into your back end and sends data down from the cloud. Or if you do have that happen, you need to be able to revoke those keys as a matter of course, and you need to be able to do that on a device-by-device level. Very, very, very key critical. So IoT Hub supports keys, symmetric keys, like most of the other things in Azure. It supports X509 certificates. It supports white labeling and black labeling of IP addresses. But the other thing that he spoke at length about was a need for durability of messaging. Okay, so you think about those small devices. Maybe it's a device out in the field checking water levels of your crops. Again, a fairly typical example. Now, that might not be on all the time, and you might not want it on all the time, because if it's on all the time, you've got to provide it with power. If you provide it with power, how do you do that when it's in the middle of a field? We have million-acre farms in Australia. Right, so it's not a trivial thing to put these things in the field and replace the batteries in them. So you need to have them, typically things like coin cell batteries, which would last 5 years. But when you do that, you have to be able to have them come on occasionally and go back off again. So they'll upload data on occasion rather than be on all the time. Now, if you're doing things like water monitoring, you can probably get away with that every couple of hours. Yeah. If you're doing other things, maybe that's not such a good plan. But because of that, you need some kind of durability of the messaging. So from a service back end, you can't just fire a message into the device if it's not on. So what you have to do is you have to have some point where that message can land so that when the device does come on, it can receive it and pull it off that endpoint. Likewise, when the message comes in, you can't always guarantee the back end is there. I mean, hopefully it is, right? Fingers crossed. But you can't always guarantee your back end is there. So if it's not, then again, you have to have durability of your messaging to make sure that you can still deliver that message at some point in the future. So if you look at the top two here, the endpoints, D2C is device to cloud, C to D is cloud to device. Essentially what we're creating there is a mailbox per device. Okay? So an inbox and an outbox. Another key point about devices is they're not always static. Configurations can change, situations can change that require your configuration to change. So IoT Hub overcomes that by a thing called a device twin. And again, if the demo gods are kind, I shall be able to demonstrate that. Fingers crossed. So essentially what that is that gives you a set of properties which are reported by the device. If those properties change from the service backend, you need an event to fire on the device to pick that information up, change its configuration, and then post back to say, I'm done. So that's what that twin is about. Methods, you may want to invoke a specific method on a device. Now, obviously, if it's a very low-powered, low-grade device, you may not have the capability of that device to do it. But imagine if it's a field gateway and you're telling it to reboot or something like that. Right? So you need to be able to do these sorts of things in real-world scenarios. The last one there on the left-hand side, obviously this side is all to do with the service side and is the corollary of the other. So the last one there is file upload. So you can imagine that you'll have a lot of devices that aren't capable of sending things very far. Maybe it's through Bluetooth. Maybe it's through Sigfox, which is really, really small bandwidth and not very often during the day. Maybe it's LoRaWAN, whatever it is, in terms of connectability. You may not want to send every one of those messages. You may want to store them on a device, and when that device connects, you may want to upload them at that point. So IoT Hub also supports file upload. You think to yourself, well, why would it support file upload? Why couldn't you just upload that file and send a message some other way? It's because, it gives you that governance, because IoT Hub is in charge of that process. So the other thing, of course, is around operational monitoring, which is come down here. So operational monitoring, you need to know the health of your systems, really. That's not just a point of IoT Hub, that's any system you build, right? So you instrument systems to get data out of it so you can log it and get some kind of insight into your system. This is no different, you have to do that, right? So the other thing I mentioned here is on that left-hand side of the screen, right-hand side, looking out, left-hand side as I'm looking at it. At the top, you see that it's got a bunch of letters. They're the protocols that IoT Hub supports natively. So it supports MQTT, AMQP, and HTTP. Right? Default is AMQP. And the service backend is AMQP. So a new thing that came in it was released pretty recently, a couple of months ago, I think now. was the ability to route messages. So instead of messages coming in and being ingested into the big ingestion engine, you may have messages that you want to fast track or for the ingestion engine to completely ignore, actually. So they introduced this ability to create routing rules based on the properties of a message. And when those messages come in, they go to a different connector rather than the cloud endpoints, the device cloud endpoint, as you can see up there. And hopefully, again, I might be able to demo that. Right, so what about some of the processing? What about some of the things that you can do with the processing? So if we're talking hot path processing, typically we'd be talking about stream analytics, but it could be, anybody a Hadoop fan? Or the Hadoop ecosystem. So the Hadoop ecosystem is recognized on Azure as HD Insight, which is basically Hadoop, but with an ability to look at Azure storage. So either of those work for the stream analytics processing, but in this particular case, Azure Stream Analytics. So monitoring, of course, windowing, so an ability to take aggregates over a sliding or a moving window. Geospatial functions. I worked for an organization that did waste management. So their trucks used to drive around all over the place, right? And they used to have geofences, things where noise abatement was an issue, and they weren't allowed to go into an area at a certain time, right? So geospatial functions would give you that opportunity of seeing when a truck goes into that area, sending a message, alerting a driver that he's not allowed to be there. It wasn't Big Brother, although they did use it for making sure that people that did speed got the right speeding tickets. But that's just the way it is. Azure Machine Learning is also easy to integrate directly into Stream Analytics. Again, that's that big scale, big data, data analytics, neural and all that sort of stuff, good stuff that Nigel talked about yesterday. I'll go through what that query is doing in a minute, but it's pretty obvious, I think. So the other thing is real-time data enrichment. So it supports adding reference data, so enriching your data as it comes through. And the last one that I'm going to mention, because it's probably one of the more interesting and more important ones, is out-of-order delivery. So you can imagine, can't you, that if you've got an environment where you're measuring temperature, for instance, and the temperature is 20, then 25, then 30, then 35, then 40, you're seeing a trend. If that data comes in completely the wrong order, how do you infer any value from that? You can't, right? So you have to have that enforced order. So if we just look at that thing on the left-hand side, right-hand side, we see that it's SQL-like, which is good, because we probably all understand SQL. And we can see there that really all it's doing is saying, OK, well, I'm going to get my stream, my incoming stream. I'm going to do 2 select statements, because you can fan this information out, so it's once in and many out. I'm going to take all of my data and just dump it into something called telemetry. So that will be some form of database, maybe Cosmos DB. And I'm going to get my other stuff, and I'm going to have a sliding window, so every 5 minutes, by device ID, where the humidity is not null, of course, because we're doing an average, I'm going to take averages, maximums, and mins, and I'm going to put that into a different location for telemetry summary, as it says there. Another recent announcement was Stream Analytics on edge, on the edge devices. So think about field gateways, right? So why would this be important, do we think? So say you've got an inlet pipe from an oil field. Say that has a pressure valve on it. Say that pressure valve is showing a trend that the pressure is going up and could create a catastrophic event. Now, going back to the IoT, what does the I stand for? Internet, right? If you don't have a connection to the internet at that point, how do you know that there's a problem? You can have catastrophic loss of life, right? So the ability to push some of this analytical workload down to a local device that can perform and give you insights on that is obviously fairly critical. I love the idea of this as well. Obviously, the stuff that's up there is the cloud, right? Edge, in this sense, is always called fog compute, because obviously the cloud is closer to the ground. I don't know if that's the reason why, but anyway, fog computing. So whoever invented that, genius. And I mentioned this earlier on. This is another thing. that came out fairly recently, time series insights. So that's a time series database, as the name suggests. Message is delayed by 1 minute, so that's why it's warm rather than hot, and why it's warm rather than cold, right? Because it's kind of in the middle. Big enough data, so it's not big data, or it can be millions and millions of events, but it only stores up to 31 days of data by default. Heat mapping I'll try and demonstrate. In fact, I can demonstrate that, at least. And you can share your dashboards. But the key thing here, and if we look at the diagram, we can see that we're zooming in, and we can see that there's been an event here that seems to correlate to other things, right? So if we know that that's, for instance, pressure, we know that this is temperature, I don't know, maybe that's density, whatever, then we can see some correlation between the events really quickly, which means we can get insights, time series insights. Oh, right, well, fingers crossed everything's going to work, right? So this is what I was going to demonstrate. The Fez hat is not working. Well, we'll give it just one more plug-in and try. So I promised that in my précis that I would have devices. So here we are, there's some devices. I've got a sneaking suspicion my Fez hat might need to be replaced. So when I saw Fez hat, I had to laugh. Anybody? So how many British people here? Not that many. Okay. So, what? Does anybody remember Tommy Cooper? Yeah, Tommy Cooper. Yeah, I moved to Australia from South Wales. He was born and raised in Caerphilly, which is just down the road from where I used to live. So whenever I see Fez hat, I have an image of Tommy Cooper in my head, for reasons I'm not quite sure. So I've got a Sense hat and a Fez hat. Is that going to work? No, it's still asleep. So we won't do the Fez hat. I've got a hot path, a cold path, and a warm path, and some action. Right? So if the demo gods are going to be kind, then I can at least show some of that. So just some tools of the trade. So this here is Device Explorer, which allows you to look at a very specific instance of IoT Hub. We have this thing, which is gone off the top of the screen, because I've resized my screen. So this is the IoT dashboard. These are just free tools that you can download. I can go up to my Raspberry Pi here. I'll open it in Device Portal. Oh, it was already open. There you are. But there we are. So what you'll notice about here is it says Windows Device Portal. This is running Windows IoT 10 Core. The nice thing about IoT 10 Core is because it's Windows 10, you can manage it with Intune and all that sort of good stuff, right? So you get all that for free. But in here, we can look at some apps, and we can look at the processes, and we can look at what it's connected to. So here I did have it connected to the NDC network earlier on, but we can see it's got an IP address and so on and so forth. So it seems to be working, seems to be happy. We'll see. But what I was going to do is I was going to show some code as well, right? But before I do that, I'm going to go to the Azure portal and show you what I kind of built. So I have my IoT Hub. I have a Logic app. That Logic app is just taking data and pushing it to Slack. So that could be your Insight Slack. Could do Twilio or Nexmo or any other SMS service. Service bus is the endpoint for certain message types. Time series insights, I'll start that up now, actually, because it does just take a little bit of time to load the environment. So, and it would seem the portal as well. Right, good. So let's let it go. So what else do we have here? So I've got the Cosmos DB account that's storing my data for cold visualization. I'm not doing any machine learning in this. If anybody wants to know some more about machine learning, Nigel is right there. Yeah, I can't see anything. And I've got Stream Analytics. So you remember those jobs, right? So my Stream Analytics job is very, very basic and simple, because the idea here is to show you how quickly you can do this sort of thing and how low levels of code is required to do it, because remember what I said? It's about the platform, right? Leverage what you've got, what's there. So, wow, this is really slow. So, my query is nowhere near as complex as that last one, which was itself not very complex. Mine literally just takes the input and pushes it out to 2 places. So, now, so with all info, when the data comes in, select everything and push it out to Power BI and Cosmos DB. So that's hopefully what will work. We shall see. So what about the code itself? I do other presentations on IoT Core and so on, and it's I did one some time ago, which was how to create an IoT end-to-end solution in 40 lines of code. Because there's an SDK, right? So you might as well just leverage it. So in this particular case, I promised you code. This is a developer conference. Please don't judge my code. Please. So, what are we doing? So we're creating a device client. That's the thing that communicates with IoT Hub. These are all in NuGet packages. So just go up here. Here's one I created earlier. So we can see here I've got something which is my Sense app, which is the thing that's on my device. I've got Microsoft Azure Devices Client, which is the SDK for doing the device communication. Right? So that's the one. Oh, right. So you can see what I'm doing is I'm creating a connection. So the device is creating the connection. So remember what I said about Clemens Vasta's work? It's about the device creating the connection. Second line there is really about creating a link between my service backend and my device, because that's for pushing data down to the device. So remember I mentioned about twins? So that's saying, okay, well, when I change my properties in the cloud, I want them to be reflected on my device. So that's just a callback. The next one is really just a method. So remember I mentioned direct method. So if I want to send something to the device, I can do it through methods. So if we go down here a bit further, what I'm doing is I'm setting up some data. So here I'm just setting the twin up. So as I'm putting an alert in, you can probably tell where this is going. I'm going to be able to change those alerts and get stuff going through to Slack. That's the idea behind the demo, right? What I'm also going to do is get a bunch of data off the device, and then I'm going to send it. It's the second to last line there. So the key thing about this is I'm sending data, but on the device, because that connection between the cloud and the device supports multiplexing, I can connect both and send and receive at the same time. So I'm also going to, so there's my send. See there, I'm just doing some testing of some values. And there's my receive. The reason the breakpoints are in there is because hopefully this will work, and I can break and show you it actually does work. So with no further ado, I shall do that. Let's just make sure that this is the right IP address. Oops. That's that, which is good. So what this is now doing, it's building. Shouldn't be building. I built it this morning. Should be quick. Yeah, so deploy started, right? So it's now pushing to the device. And what we should see, if we go to the camera here and move that one out of the way because that's not actually working. So this will just take a little while just to upload. So we'll come back to that. You can see it's deploying. But what we'll do is we'll come in here and we'll try and monitor the events. This is the bit that wasn't working earlier on. So fingers crossed it will work this time. And we'll be able to see the events coming through, and then we'll be able to do some playing around with it, right? So that's the idea behind the demo. So whilst that's loading, what I might also do then is go into time series insights. Right, so good. So we'll come back. This is older data, so we'll come back to the live demo, for want of a better word, in a little while. So time series data is that warm analytics path, delayed by a minute, allows you to get some further insights. So what I'm going to do is I'm going to say, OK, this is the data that I've been playing and sending around over the last couple of weeks, or last couple of days, rather, since I've been in Oslo. And you can see I managed to send quite a bit of data on that point there. So what we can do is we can drag that, zoom in. Now, I haven't done anything to this. This has all been pre-calculated, right? So I've, other than send the data to time series insights, I haven't done anything. So you get all this, I won't say for free, but you know what I mean. So I can choose in here, I'm going to choose light, and I'm going to say split by device ID. So the Fez hat, which was this thing here, has a light sensor on it. That was going to be one of my demos. Unfortunately, it's not now. So that's going in the bin. That's not going to be. But you can see here that there's two devices, Sense Hat and Fez Hat, and there's some data. The Sense Hat doesn't have a light sensor. That's why there's nothing on there. So we can overcome that just by putting something in here. Devices. Excuse my typing. Fez Hat. Apply. So let's remove that data, right? So we can see there was something going on here. So why don't we just zoom in a bit more on that? Zoom. We'll change this to be a bit more granular. And we can definitely see that something was going on, right? Something going on over here. I wonder what that was. I know, I was there. But so I remember you saying about the heat map. I can go to heat map, and I can immediately get a very, very quick visual representation of outliers, anomalies. Right now, obviously, there's a lot of anomalous data there, or maybe I don't think that's anomalous. Maybe I think the low numbers are anomalous, and I can then go and zoom in that area as well. Go back to the chart, and what I'm going to do is I'm going to add another term, but this time I'm going to do device, oops. Is equal to sense hat. Apply. And I'm going to look at humidity, because the sense hat has a humidity sensor. So there we are, humidity. So if we look at the times of this, that's 3 days ago, 3 days ago? Yeah, 3 days ago. UTC, so it's 3:30, roundabout, something like that. Something happened at that point. It's a bit strange. And we can see that at that point there was a lot of light, but then this seems to have tailed off, and then the light disappeared. So what do we think was going on there? So let's just zoom in a bit more there. So can anybody have a guess as to what was going on there? Humidity went up, and then suddenly the light disappeared. Okay, I'll give you another clue. I had my Fez hat, which has got the light sensor, in my room, and I had the Sense hat in the bathroom. So what do we think may have increased the humidity in the bathroom? I took a shower, right? Oh, well, that's just awesome. Goody. So we'll try that again, and maybe we'll just quickly run through that. Yeah, so I had a shower, basically. And the reason it got dark is because I took my card out of the room, and the lights went off. So, yeah, it's pretty obvious to infer when you know some information about it. But what I can also do is I can look at the events. So again, I haven't had to do anything for this. This is just ingested directly, and it's done all these calculations for me. And now I can start drilling into the events as well. Pretty cool stuff. And of course, what's even better than that is I can go, hey, Mr. Production Engineer, Look what I found. So I can just send them that URL. And I can save these dashboards and go really, really nuts with them if I really want. So again, it's all pretty powerful stuff. So is this running? There were deployment errors. So this has gone to sleep as well, isn't it? Okay, well, why don't we do things the hard way? Just plug that directly in case that hub's a bit knackered. Right. You can see, though, that it did display the temperature when it was working. So it's 33 degrees. Wow, that's kind of warm. Right, so that's coming back to life, I think. Maybe? No. Maybe it's the hub, so we'll get dispensed with that. I only had the hub because I was going to be doing stuff directly with 2 devices. Come on. So this was all working this morning in the bedroom before I came. So I should have just invited you all. That's probably wrong. Probably wrong. Right, we'll see if that comes back. If not, we'll dispense with that and we'll talk about some other stuff. However, right, moving on. So the other thing I would have shown you is the live data. So just recently, Power BI introduced the ability to take streaming data sets. So if this was working, that would also be working. That really is dead, isn't it? So I wonder if I take that out, if it's actually there. I did turn the Wi-Fi off, which probably wasn't the brightest move. So there you go. So it was working briefly, just a little bit of time ago. So it was actually sending data. So that's what was being displayed about, this is, 2 hours ago? So it's an hour ago. So it was working when I arrived. Now there's proof. I'm not making that up. And of course, what I would have shown is that temperature going up, and just by pressing the temperature sensor and the light as well. What I'll do is I'll move on because demo gods haven't been kind. I obviously didn't pray hard enough. So I'll just come back to this because it's still important, I think, to show this because it shows the way this process does work. So if I go into management up here, I can see my devices. Please don't copy those keys. It's saying it's connected. Interesting. Because it clearly isn't. So this is that device twin that I was talking about. So the thing that has the cloud representation of the state of my device. Right? So I've got these reported properties. So that's what was in my code. So 35 and 20. And what I can do, although it won't work, what I can do is go in here and I can literally update that, press send. Like I say, it won't work, but oh no, it might have done. And Bob's your uncle. It's updated the configuration, right? So it's clearly not receiving data though. So I can try it one more time. Maybe it did connect back to the Wi-Fi. No, obviously it isn't because it's not changed the number on the front, right? So, but I could also send messages from this device, from this to the device, and I can call methods. So, very, very useful tool if you're playing around with these things. Device Explorer. I urge you to make it your friend. So the other thing that I was going to show is Power BI. So if I go into Power BI, this will work. So a few days ago, I downloaded some data, and I started making a dashboard. My skills in Power BI are not as good as, well, frankly, most people's. So apologies for the somewhat rubbish looking of it. That's loaded, good. So we can see here that what I've just done is very simply, I'll put a couple of things on here just as examples. This is the acceleration. I've got light and humidity, light and temperature and humidity, and I'm able to slice this data and do what it needs to do by time or by device, right? So when I'm happy with that, so this is to satisfy that need for the cold path. So what I did is I downloaded all this data from document DB. Sorry, the name's changed, Cosmos DB, and pushed it into here. And all I need to do with this then is I publish, hit publish. Do you want to save your changes? Yeah, why not? This doesn't take very long, thankfully. In the meantime, whilst it's doing that, oh, yes, please select yes. Select. We'll give this one very, very final go. Because yeah, we want to show the demos, don't we? Let's do that way around. Publishing, publishing, publishing. Done. So, now I'm going to go to Power BI. Where's that gone? Down here. There. What we'll see, if I refresh that, is a new report, which will be that dashboard, that report that I just created. So there we are. Oh, wait. There it is, weather data. And we can see that's the what I was just playing around with inside in Power BI Desktop. So I've published this up, and I can do all the same stuff. I can slice and dice as I need to. But you'll notice this data's old, because it's from a couple of days ago. Not spectacular if you want to do long-term monitoring of things. So you overcome that by going down to your data set, clicking refresh now. Hopefully it's remembered my credentials. Can't refresh your data. It hasn't remembered my credentials. This is really going extremely well, isn't it? So we'll just go in here and we'll just grab my key. Please don't make a note of this. And obviously when you're videoing this, make sure you blacken this out. I'm just saying. This Cosmos database will be going to by the end of today, don't worry. So it's aware of time as well. So I'm just going to go in here and go keys. Copy. Right. Sign in. There we go. So that says data source updated. That's good. That's what we want. Refresh now. So now it's going to go away and refresh it. So good. That's done that. But of course, again, it's still just a static dashboard with that data in it. Right? So from the perspective of having that cold path analytics where you want to be told and do your batch analytics, it's still not spectacular. What I can do is I can go in here and I can set up a scheduled refresh. Right? So keep my data up to date. Yes, I can do that frequency, daily and weekly. Obviously, I can tell the time that I want it to do it. And that will then keep that dashboard up to date. Right? So that's my cold path analytics, if you like. If I go back to that dashboard, or the report rather, you should see that will update. So it's pulled in the other data. Interestingly, it's pulled in data from today, so as I say, it was working. Honest, it was working. And now I can slice and dice this and do as I need. Oops. So we'll take something like that, right? Whatever. So this is still not working, so that's fantastic. So we'll go back to deck. Right, so I'll probably finish about 5 minutes early. So apologies for that. So I want to go back to this slide, just to kind of re-emphasize, really, I suppose, the message, which is you have things. They can be capable, they can be not very capable. There's actually an SDK, or the source code for the communication in and out of IoT Hub. It's all C. You can compile it yourself, so you don't have to use an SDK. There's SDKs for Java and Python and various others. C#, of course. Insights. So how am I going to get some of my data and get some additional value out of it. So again, a bunch of stuff there. Last thing there is about connectivity, really. I'm an integration guy. I'm known in Perth as a person who can always fit the word BizTalk in any kind of conversation. So I've done that now. So I've got that out of the way, so that's good. So Logic Apps is the way we do this nowadays, of course. And really and truly, the rest of it's around about that value chain. So we don't build hardware in the software integration or the systems integrator that I work for. We have a hardware partner. We have our own data scientist, but you can hire those kind of guys in, right? So don't be put off by the fact there's a lot of stuff there, but I would definitely urge you to try and play with as much of this stuff as you possibly can, because it allows you to get that understanding, and that's what this talk was about, really, about getting an understanding of how you might deliver a real-world solution in the world of IoT. And I think probably with that, we've probably not quite out of time, but this isn't working, so it would have been about another 5 minutes longer, so I think that's probably it. Yes, it is, right. So that's my Twitter handle, if you want to follow me, and that's Cecile. So that's it. Thank you. And as we have a bit of time, questions? Yeah.
Yeah, one question about the warm analytics.
Hang on, let me just get off the stage so I'm not blinded. Yeah.
Say you've got your time series there.
Yeah.
You have some functionality to do analytics within the Azure platform, but some analytics you'd probably like to do in code yourself with C#, for instance.
Yeah, you can do that. Yeah. So there's a few ways you can do that, right? So you can, if you really so desire, create machine learning models to do that. But you can also use a thing called Azure Batch, which allows you to run C# code and all that sort of stuff at massive scale. It's also used for things like computational fluid dynamics and all that sort of stuff. Monte Carlo simulations, that sort of thing. So there are other services that will allow you to do that, yeah.
Right.
Yeah.
Do you know any services with principal component analysis or that kind of?
Sorry?
Principal component analysis, if you want to do early fault detection.
Well, again, machine learning would do that, right? So I think Nigel mentioned it briefly yesterday. There's an anomaly detection API in the Cortana Intelligence Gallery. So you can use that, and you basically throw a data set at it, and it tells you any outliers. So if you're doing fault detection, that's pretty useful. But actually, in the gallery, there's lots of other things as well. People build these APIs and publish them for you to use. So you can just use those as well, right? So there's a lot of stuff there. Does that answer the question? Yep.
You talked about pushing code, pushing files.
Yeah.
How would you do code upgrade or application upgrades on devices? Would that be Intune?
You can, if you're using Windows 10 IoT Core, you can use Intune. Otherwise, you can. That's the way that the direct methods and all that sort of stuff works. It allows you to basically do over-the-air upgrades of the core system, or reboots and so on and so forth, right? So all that is part of the device management. So if you run the SDKs, you get that device management, and then you just wire it up.
Mainly for Windows 10 IoT?
No. Other systems as well. Yeah.
So if you have a node application running on a small gadget?
Maybe. I wouldn't like to comment for sure, but possibly, yeah. But I mean, it depends on the volatility of your code, right? So if you know your code is unlikely to change very often, I think it's probably fair to say, once you've built your device, because then you deploy it into the field, right? So
But when you then have thousands of devices in
yeah,
the field,
exactly.
you need to upgrade them.
So what IoT Hub supports is a thing called jobs, device jobs, and that allows you to schedule across a large estate of devices upgrades, such as you're talking about, right? Upgrades and configuration changes and that sort of thing, right? Yeah. Any other questions? I think we've still got a couple of minutes. Oh, yes. Oh, right.
I was wondering about the time series insights.
Yeah.
Where does it get this data? Do you have to find it document DB or something? Or
Yeah, so actually it's even simpler than that. So that's a very, very good question. Let's just get rid of that so as you don't copy it. I'm joking. So here we have time series insights. And we can see it says event sources. So this is the power of the platform, I suppose you could argue. I can go up in here and just point it directly at my IoT hub. So IoT hub, like Event Hub, uses a partition consumer pattern rather than a standard messaging pattern that you might get in a queue, which is a competing consumer. So you have competing consumers on a queue, which says, OK, I'm going to grab this message, I'm going to grab that message, and so on. Right? You can't do that with large-scale streams. You have to have a thing called a partitioned consumer. So what you have inside IoT Hub and Event Hub, because they're built on the same stuff, is the idea of a consumer group. And when you start reading data off of that consumer group, which is just the stream, as you're reading that data, you just checkpoint. Say, I've got to this point in the stream, I've got to this point in the stream, I've got to this point in the stream. And at any point, you can wind back and start processing the data again. So the only thing you need to make sure is that when you're consuming things, you just set up enough consumer groups so that different consumers can consume the data at different volume and different times and so on. Right? So time series insights here, what I did was I set up a different consumer group. So I think that usually shows and displays on the screen. So I set up a consumer group called time series for that particular one, and my stream analytics is reading from a different consumer group. So they're not competing for messages on that consumer group. But literally, it's wiring up. There's no code involved in all this. It's just literally wiring up. Any other questions? OK. Thank you very much. You've been my favorite audience so far.